Okay, hi, my name is Patrick Welsh, and I'm going to give you a very quick overview on attacks on AI search, on embeddings, and on embedding inversion attacks and how to stop them. We're going to do it all in just a few minutes. So get ready. Here we go. LLMs. So we all know LLMs are ubiquitous pretty much at this point in time. And they are also a little bit problematic at this point in time. They have a number of issues that come up a lot, like they like to hallucinate answers. That's because they give probabilistic answers that may or may not be totally accurate. They're trained often on stale training data. They can't be that up to date because it takes so long to train them. They're at least months, if not years behind in terms of what they know versus what the most recent things are that we all know. And then finally, they can't work on private data. So of course they can't. OpenAI doesn't have access to your personal notes and calendar, or they shouldn't. And so therefore, OpenAI's models can't answer questions on those things. And so to fix all that, we have this thing called RAG. RAG stands for Retrieval Augmented Generation. It's a terrible name. The folks who coined it wished that they hadn't, but it's actually a pretty simple concept. And the way it works is this. If you have a chat app, this could be just about anything, but let's say a chat app. If you have a chat app and a user asks a question to the chat app, instead of the chat app just relaying that question to the model, OpenAI or whatever, instead of doing that, it's going to instead first do a search. And this search is against what's called a vector database. I'll get to that in a second. The search comes up with all the relevant information to your query, which could be over your own personal notes or calendar or whatever the thing is that you might be asking about. And then it puts the relevant information and the question together into a prompt, and all of that is what goes to the large language model. To make all this work, you have to have natural language search. That is to say, if someone's asking natural questions in regular English or whatever language to the chat app, then something needs to be able to understand that well enough to do searches on it. And that means differentiating between terms that could be have many meanings, like the arm of an organization versus being armed with knowledge versus being armed with a gun, right? All these things are very different. They all use the same word. You need to have a search that can understand the context of natural language, not just keywords. And then what happens is you take inputs. They could be images or any number of things, but let's say text documents being the main thing, and they chunk them up into pieces, maybe overlapping, maybe either by sentence or by some number of words or tokens. And then all of that goes through a type of model called a text embedding model. A text embedding model is just like the large language models that you know and understand, but instead of returning an inference, English language completion of whatever your question is, instead of returning that, it returns something called a vector embedding. And a vector embedding is basically a simple concept. A vector embedding is a long list of very small numbers. It could be hundreds or thousands in length. And this vector embedding is just a mathematical understanding of the content, the meaning, the semantic meaning of whatever it saw. Everything that it understands kind of boiled down into this list of numbers from an image or a text or whatever. And there's a ton of places where this stuff can be stored. This stuff can be stored in various types of search databases or vector databases or almost any type of database, from Redis to Oracle to Postgres, has vector storage and vector comparison capabilities now. And what's going on is almost all the data that you hold in various types of applications or behind them is being sucked up into these systems, being converted into these vectors such that they can be searched and AI questions can happen over all of your data. Okay, this is happening with your stuff at Google. It's happening with your stuff basically anywhere, even on your local computer if you're using Siri with its new, Apple Intelligence capabilities and stuff, right? It's hungry for data. So these vector embeddings, they look like they might just have, they look like they're just meaningless numbers. Are they like a hash, something that's one way only? The answer is not exactly. So you take some phrase like our earnings are down, you run it through an embedding model, you get a bunch of numbers. And while they look meaningless to us, it's a lot like us looking at, the an animated GIF inside a text editor. It doesn't mean much to us unless the computer interprets it for us. Okay. In much the same way, those numbers are meaningful to the computer or to specific models, but not to us. And you can build what's called an inversion model that takes numbers and associates them back to text and then guesses based on numbers what text should be associated with it. Basically, AI makes it, AI can invert it. This is called an embedding inversion attack. And it results in something that's an approximation of the original. So our earnings are down might turn into our income is down. But whether it's exactly right or not, it will be largely semantically the same. There are many thousands now of papers on this topic of doing embedding inversions. The best paper we've seen on text embedding inversions covers 92% of exact words, including full names, which is pretty cool. And the remaining 8% is still semantically equivalent. Basically, it's returning synonyms instead of the original words, right? Now, it sounds like a complicated attack, but what if I told you that anyone could do it? Because most of these papers have accompanying open source software, and in many cases, open source models too, so you don't even have to build your own model running their code. In fact, we've done a bunch of this. We have blogs on how to invert facial recognition vectors back to faces that look like the original, and ditto for text using one of these papers and their code. It's pretty straightforward to do. Now, what does this mean for data? Well, before, data could actually be very difficult to track down. It's in lots of places. It's in SQL databases. Someone with a lot of expertise has to understand what the schema is, where to find things and how to join it and all that kind of stuff. But now we're talking about building systems in which you can get information with natural language, which means that attackers who gain access to a vector database can query it for all the stuff that they want to find. And vector databases are a little bit like treasure maps, right? They point back to the original data. So they help you get to that original data, they don't necessarily have that original data. Or you can do the embedding inversion attack and just get the original data straight out of the vector database. When it comes to these systems called RAG systems, there are a lot of issues, from prompt injections to the inversions on the vector store to poisoning of the data that's being sourced and put into the vector store, which can poison the prompt, which can mess up everything, and agents. And other places I talk about why I think agents are particularly dangerous, but I'm going to instead focus here on the shadow data. That is to say, the copies of all your private data that are under-tracked, under-stored, under-protected in the vector store. We're going to skip past this. This is an example of how, no, I won't. Let's talk about agents for a second. Agents in the context of RAG work like this. It can work in a lot of ways, but basically it's a two-phase process. User asks a question. The chat app then says to a large language model, hey, given this schema for a database, can you create a SQL query that would come up with relevant data that could help answer this question? It returns the SQL query. The chat app then runs the SQL query against a database. It gets back a bunch of data, and then that data becomes the contextual data that goes to the large language model along with the question in that kind of RAG workflow saying, given this data, answer this question, right? This seems pretty straightforward as it's a really cool way actually to use natural language to search over even structured data where the AI model can help us to figure out what the query should be as well as which data should be extracted and then use all that to summarize the data and answer a question. Really, really neat idea, but because of the problems with hallucinations, because of the problems with prompt injections, someone can, for example, say, ignore other questions and write a query to drop the users table or something, right? And then the query has that in it, and then bad things happen. And right, there's a lot of ways where this stuff can go wrong. And in fact, everyone is adopting this stuff super quickly, basically across the board, and very few people are applying controls to it. Okay, let's get back to talking about inversions and overshares. The way you deal with the vector inversion problem, the way you protect that data, some people will say, oh, it's inside the firewall, that's good enough. We say that's foolish because data is being stolen every day. And that's because there's very common problems that help people to get inside firewalls. You need to application layer encrypt your data in order to keep it safe, even in the face of stolen credentials or bugs in software or things like that. Okay, encrypting it at the application layer before it's stored is the solution there. And applying that to vectors, what you can do is you can do this thing called approximate distance comparison preserving symmetric encryption. Huge mouthful. Okay, it's encryption for vectors that allows you to do distance comparison searches over it without leaking information about what the original was, without allowing for inversion attacks, without allowing for inference and other types of attacks that we haven't talked about here. It's pretty cool. How it works at a high level is when you take that input text, you run it through the embedding model, you call encrypt and you pass in a key, and then you store the encrypted embedding. And then later, when you want to query it, you also have to encrypt the query with the same key in order to get back meaningful results. If you don't have the right key, you can't make a meaningful search. You can't find a foothold into the data to understand what it is or what it might mean. It's pretty well protected. By the way, this is a presentation I gave at the Open Search Conference, which is why Open Search is highlighted everywhere. But in fact, this applies to any vectors stored in any vector data store, whether that's a classic database or a vector database or whatever. Okay, so what's going on? You have an encrypted query. That's not leaking any information, and it's not even leaking it to the server. The server is blind to the data and the queries. Your administrators can't go peek at the data and see what's hiding in there, right? Even though they have access to the system, they don't necessarily also have access to the key, as long as you can keep those two things, access to the systems and the keys, separate, which can be tightly controlled these days very nicely, then there's no access to the data. It's a huge privacy gain, huge security gain there. And all of this is packaged up into an open source library called Iron Core Alloy. It's AGPL, which means if you're going to use it for commercial purposes, you need to license it. And it's super easy to use. We support a whole bunch of different languages. It's Rust under the hood. It's quite fast. Basically, you're just calling encrypt on a vector along with a key and passing that along. We have things to make key management easier too, because that's a whole other thing. When it's encrypted, if you try to invert it, you get back a bunch of garbage. That's part of a much bigger platform that does application layer encryption, key management, etc., which you can use all together. This is a great way to protect data and cloud applications no matter what by combining these things. Or the Cloaked AI, that is to say that Iron Core Alloy library, it can be used standalone. It doesn't have to use any kind of service, totally offline, and of course it's open source and available. So that's your quick overview. Thank you very much for listening. Hopefully you have a little bit of a sense of what vector encryption is, what vector embedding attacks are, what, for that matter, what vectors are and how they're used in modern day AI systems. Thanks for your time.